Hello students, welcome back. In this video we are going to go through chapter 9 section 2, which is now we are dealing with two means, two samples, two means, and we're trying to make inferences about that. Remember our last section we dealt with two samples and we were making inferences regarding their proportions. Now we are doing means. So right now we are going to be hypothesis testing about two population means, and then we're going to be doing confidence intervals as well. And a conceptual example is going to be looking at regular Coke and Diet Coke. So we are looking at the claim that cans of Diet Coke have weights with a mean that is less than the mean for regular Coke. So you have two samples. They are independent of one another. That's important because we will deal with dependent ones next section. So we're dealing with two independent samples, and then we are making inferences about something regarding their mean. So again, as you should know this, two samples are independent if they are unrelated to one another. So it has no effect on the other. And then, as you probably figured, dependent means that they are somehow matched, that there is some kind of relationship. So the objective here is to do hypothesis tests and confidence intervals for these types of problems. So just to go through the notation now, we have our mu1, so same notations, just we're adding subscripts. So mu1, x bar 1, sigma 1, s1, n1 are all the same, just of the first one, and then add a subscript of 2 to apply it to the second sample. Requirements are similar to the previous one, that we don't know the population standard deviations. The two samples are independent. They are simple and random, and then they are both either normally distributed, or they are large enough where the n1 and n2 are both greater than 30. So similar requirements, just adding the fact that we are dealing with two samples this time. So the test statistic, we had the one equation when we dealt with one sample. Now we have two samples, so the test statistic becomes this equation right here. We have our, similar to section 9.1 where we had P1 equal P2, now our null hypothesis is mu1 equals mu2. And our test statistic equation now becomes this equation right here, where if we have our null hypothesis as u1 equals u2, this value right here becomes 0. So similar concept to the test statistic in section 9.1 as well. So degrees of freedom. So use the simple and conservative estimate, whereas the degrees of freedom is going to be the n minus 1, and we are working with whichever is smaller. So we'll be conservative here. So if you have two samples, one sample has 10 and the other sample has 20, when we're using that chart for the degrees of freedom, you use the one that's smaller. So in the example I just provided, you would use the one with 10 data points. And then we will, so technology actually uses a more accurate and convoluted equation to be able to get degrees of freedom, which kind of interpolates to get somewhere in between the values of both, depending on how much significance each one provides to the mean. But you won't have to do this one by hand. This is just showing you where your computer or where your calculator is going to be getting their value from. Again, this equation right here just incorporates both values. Your conservative estimate, for the sake of being able to use that chart, is only going to deal with whichever is smaller. So we have our p-values and our critical values. Again, you're using the t distributions and then table A3. And then confidence interval, similar to what we did in section 9.1, you have your lower bound is x1 bar minus x2 bar minus the margin of error, and then the upper value is plus margin of error, and then you're saying that your null hypothesis is going to fall in between then. Again, if our null hypothesis is that u1 minus u2 is 0, you are looking to see if they are if the lower limit is negative and the upper limit is positive, and then that would include 0, or if this is positive and positive, it would not include 0, or negative, negative, again, it would not pass 0. And the margin of error is given by this equation right here. Okay, so for equivalent methods, the p-value method, the critical value method, and the confidence interval all use the same distribution and standard error. So for independent means, they are all equivalent, and that they all will always come to the same conclusion. Remember, that is not the case when dealing with two proportions. We said that the p-value and critical value were equivalent, but not the confidence interval. But for this section, where we're dealing with two sample means, they are all equivalent methods. So similar to how I did it in section 9.1, we're going to look at one example, and we're going to solve it several different ways, both p-value, critical value, and confidence interval, both with and without technology. So this is an example that we did in a previous section, I believe, and it is the course evaluation scores for courses taught by a female professor and male professor. We're going to use a 0.05 significance level to test the claim that the two samples are from populations with the same mean. So we're looking at the mean score for male and female teachers, and then see if there appears to be a difference in evaluation scores taught by female professors and male professors. Notice that the male professors have more data points than the female professors do. So first step, check your requirements. We are good. Woohoo. We'll solve it 3 ways, like I said before. So let's now look at the p-value method without technology. So we have our null hypothesis is going to be u1 is equal to u2, which makes our alternative hypothesis that they are not equal. So u1 does not equal u2. Significance level is 0.05, and then we will be using a t-distribution with the test statistic given by the equations earlier in this section. So we have our large formula right here, and then we have to use our data points over here, and we're going to have to get our sample mean and our sample standard deviation for both of these. So you should know how to do that with your calculator. And once you do that by creating, you can either do that with StatCrunch is easy, or I always like using my TI-84, but either way is fine. You get your female values of n equals 12, your sample mean is 3.866 repeating, and your sample standard deviation of 0.563001, and then here are your values for when you get the sample statistic for the male sample. Plugging in your recently calculated values into this equation gives you a test statistic of t equals negative 0.660. So once we have our our test statistic of negative 0.660, we look at table A3. So we have to look at whatever is smaller. So since there are fewer female data points, that will be the more conservative estimate. So we'll do 12 minus 1. There were 12 female data points, 15 male. Since 12 is smaller, we'll use that, and 12 minus 1 is going to give us a degrees of freedom of 11. So with the degrees of freedom of 11 and a two-tailed test, A3 indicates the p-value is greater than 0.2. And just note what technology will give you, but we'll get to there in a little while. So because the p-value is greater than the significance level of 0.05, we fail to reject the null hypothesis. And as the ever so catchy jingle goes, if the p is low, the null must go. So the interpretation from that, from step 7, is that since there is not significant evidence to warrant rejection of the claim that the female professors and male professors, oh, sorry, I read that kind of in a weird in fluctuation. There is not significant evidence to warrant rejection of the claim that female professors and male professors have the same mean course evaluation score. Okay, You can also solve this using technology. So the tricky part about the preceding p-value approach is that the table A3 can only give you a range for the p-value, and it can often be difficult. So technology automatically provides the p-value, so technology makes the p-value method quite easy. I'm sure none of you will actually type in those complicated formulas. I'm sure you just use this method, but I like to show you the without technology method just so you know where these values are coming from. If you were stranded on a desert and you had to figure out a p-value for something and you don't have the ability to run a program, would you be able to solve it? Well, maybe that wasn't really a good scenario to make you think that this stuff is going to help you survive, but hey, it can help you with a job. So over here, this is just showing you a summary right here. Let's go to an actual step-by-step. Again, I'm showing you with the TI-84. You can also use your textbook to solve it with StatDisk, Minitab, Excel, StatCrunch. They're all really easy and kind of self-explanatory once you kind of get started. So we weren't given a summary of the data. We weren't given the sample mean and the sample standard deviation. We were given actual data. So we need to get the mean and standard deviation from the sample. So to do that, first, before we do anything else, we have to make a list and then have the TI-84 analyze that list to give us the mean and standard deviation. If you do this with StatCrunch, you can probably do it all at once if you type in all of these data values, and then when you do your analysis, you do it from summary or data. You would choose data. Summary is if you had the mean and standard deviation and the end value. Data is if you want them to read your values over here. I think next video I'll do that just to show you what it looks like. So on your TI-84, press Stat, press Enter to get to the one edit tab. Then populate your list with these 12 values. Right, there's 12 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. And then populate list L2 for your male teachers. There's 15 datas. And then press second mode to quit. Just all we did right now is just populate a list. And then on your TI-84, now press Stat, go to Calc, press Enter. So when you go to Calc, you hit the right arrow once. And then we're going to hit Enter for one variable statistics. And then for your list L1, it will give you your information that you're interested in, and you have to do that a second time for L2. You also could just do the next step and do it for data, not stat summary, but I'm just showing you a method to do it. Always realize that there is several ways to solve these problems, not only the solution method I'm showing you. Okay, so at this point, we just did two lists, and we just got our sample mean and our sample standard deviation for both our lists. So now we actually have to do our hypothesis test. So now we're doing the hypothesis test. So we're hitting Stat, we're going over to Tests, we're pressing 4 or scrolling down till we highlight the two samples t-test, and we're going to enter our data as follows. And then once we calculate it, we get these values. So we get a p-value of 0.517, and because the p-value is greater than the value of 0.05, we fail to reject the null hypothesis. So finally, we will be doing next we'll be doing the critical value method. And this is generally easier than the p-value method. So we have n1 equals 12, n2 equals 15. So we are going to be analyzing with the n1, so the degrees of freedom is 11. So degrees of freedom of 11, alpha is 0.05. We get critical values of plus or minus 2.201. The test statistic was negative 0.660, as you can kind of see right here. So if that would appear not in the green shaded region, so we fail to reject the null hypothesis. Finally, we are going to be doing this with the confidence interval. So we want to do a 95% confidence interval. First, I'll do it without technology, then I'll do it with technology. I gave you the equations earlier, so we can have our margin of error right here. We'll be using our critical value that we get for t, plugging and chugging. Boom, margin of error is 0.422452. Plugging into your interval ranges, you get a lower limit of negative 0.55 and an upper of 0.3. Notice how one is negative and one is positive, so it is passing 0. So we are 95% confidence the limits of negative 0.55 and 0.27 contain the difference between the two means. Because the limits contain 0, 0 falls between these two values, it suggests that there is not a significant difference between the mean evaluation for male and female professors. Finally, I'll show you how to do the confidence interval with technology. So press stacks, go over to tests, press 0, or go down to 0 for a 2-sample t interval. Enter the data as follows over here. Hit calculate, and then you should get this value. Again, it gives you the same value as by hand, and again, since the limits contain 0, there is not significant difference between the mean course evaluation scores. It could fall in either way. So therefore, we solved the same problem several different ways, yet came to the same conclusion. Woohoo! All right, thanks guys.